Today, we are dealing with beggars taking turns. We are looking for loose change in our pockets and on the couch. We are summing together the values of nodes and binary trees. We are zipping together two arrays with a single function. And then, we learn of the tale of Josephus. Hello world, and this is Versus Codewars. We begin today with the warm-up segment, a series of easier katas in order to prepare us for the more difficult katas later in the episode, starting with removing elements from an array. Given an array, the goal of this kata is to remove every second element from the array. We keep the first element and we start removing with the next. Let's go ahead and get started with this one here. Const remove every other. That's going to be the name of our function here. It's going to take an array as an argument here, and we are going to use the array object's filter method to remove every other element from this array. And we can do that by doing this, array.filter. And in our predicate function, we won't need the array element itself, but we will need its index. And this predicate function will return true if the remainder of index divided by 2 is equal to 0. So, anytime this predicate function returns false, that corresponding element gets removed from the array. Let's go ahead and punch this into Codewars here. And we are good on that. Our next warm-up kata. We are playing a game of Duck, Duck, Goose. The objective of this game is to walk in a circle, tapping on each player's head until one is chosen. Alright, consider this function signature right here. We are given an array and a number. This array represents the number of people whose heads we are tapping, and the number here represents when we should stop tapping heads. When we say goose, that is. Let's go ahead and give this one a try here. I think we've already got some names loaded here in this kata solution here. Alright, let's go ahead and give this one a try here. Const duck, duck, goose. And we have our array of players, and we have our goose number here. And what I think we end up doing is we'll go ahead and return players at goose modulo players dot length dot name. Alright, where I'm getting at here is note the calls to this function right here. We have our array of players here, A, B, C, and D, and for example, this second one here, we have 5. And it should return a.name. Now, here's a little trick you can use when indexing array elements using the modulo operator here. You take the element that you want to index here, and in case that should fall out of range, you take that index and you divide it by the length of the array and get its remainder. That remainder will be the index of the element that you would like to get here. This ensures that if you supply an index here that is out of range, that this will wrap around to the beginning of the array, always getting you a valid element within the array. And given the fact that this should return a.name, we have this .name right here. Let's go ahead and punch this into Codewars and see what this looks like here. And let's run the tests. And what's going on here? Expected A, instead got B. Oh.
2, 3. Oh, 1, 2, 3, 4, 5. Oh, okay. This is base 0 here. So we were 0, 1, 2, 3, Okay, let's try this then here. Instead of Goose, try Goose plus 1 here. Or maybe minus 1.
And we are good on that. Our next warm-up kata, we are given a non-negative integer, and the goal of this kata is to return an array of the individual digits in order. Let's go ahead and give this one a try here. Constant digitize, and we have our number right here. Now, in order to pull the individual digits from a number in our past katas here, what we have been doing is we have been doing something like this. We take the number, we convert it to a string. We split that string into its individual characters with a late string separator. And then we run that resulting array through the map method, taking each character and using the parse int function to convert those characters into digits. And that should be sufficient right here. Let's go ahead and punch this into Codewars and see what this looks like here. And we are good on that. Our next two warm-up katas are related to one another. First, we are taking a linked list and converting it into a string. First, let's go ahead and take this class here and copy this into our kata solution right here. Consider this class right here. This is a node, and this is a commonly used object in the implementation of linked lists. Pay mind to the members of this class here. You have your data for this node, and then you have a pointer to the next node in our linked list here. And keep in mind that the parameter next in our constructor defaults to null. Alright, let's go ahead and give this one a try here. The goal of this kata is to take the members of this linked list and stringify them. Convert them into a string that works something like this. Alright, let's go ahead and give this one a try here. I'm going to go ahead and hit train. And what we're going to go ahead and do, we're going to do const stringify. And we have our linked list. Let's call it the root node for the sake of this kata solution here. And for the sake of our linked list right here. And what we'll go ahead and do is we're going to go ahead and keep track of an array, keep track of our list data members inside of an array here. And at the end here, we're going to go ahead and return that result joined together with a space, arrow, space right here. Alright, let's go ahead and do this. While root node, or rather, do while root node, or rather, go ahead and keep track of a next node here too. Do next node. Actually, no. What we'll go ahead and do, we're going to go ahead and, yeah, let's just do that. Let next node equal root node. And we'll do a do while loop here. Do while next node is not null. Or rather, next node is equal to false. I'll bring back this little double negation operator trick here to coerce this into a Boolean here. I think that might be a little more readable. Anyway, what we'll go ahead and do is we're going to do result.push next node.data. So we're going to take the data in this node here and push that into our result array here. Next, we need to go ahead and set our next node to the next node linked to this current node right here for our next iteration here. I'm going to do that by doing this, next node.next. Alright, let's go ahead and try this in Codewars and see what this looks like here. I'm going to run the test here. And what is going on? Cannot read property data of a null. Okay, let's go ahead and console.log this and see what this looks like here. Console.log next node.data. And then we'll do next node equals next node.next. Alright, let's go ahead and see what happens here. We're going to go ahead and take one of these test cases here. I'm going to go ahead and copy that and paste that into our local solution here. Console.log. Alright, let's go ahead and test this out in Node here. Node warmup stringify linked list, and we have a 0 here. Why do we have a 0 here? Okay, well, next node is equal to null. Is not equal to null. Yep, that I think did it there. In most part here, because we also need the null at the end of this as well. And what I think we'll go ahead and do here is we'll just go ahead and do result.push null. No. And this is actually supposed to... Oh, wait a minute. Yep. I'm doing this console.log here instead of result.push. I'm just going to go ahead and do next node.data. And we're almost there. We just need the null at the end here. I think what we'll just go ahead and do is result.push null. I might need to make the... I might need to stringify that here. Nope. Alright. Okay, where are we going wrong here? Alright, we have our stringify function here. We have our root node right here. Alright, we keep track of the data in each of our linked nodes in this array right here. And we keep track of the next node here, which we initially set to the root node that we pass in here. I think we... And then in a do while loop, we go ahead and push that push the data in this current node into our result array. And then we go ahead and set this next node right here to point to the node linked to this current node here for the next iteration. And this loop continues until we run into a node that is null. I think I know where I'm going wrong here. If next node is equal to null, we'll go ahead and do result.push and put a null string here. I think that ought to do it. Let's go ahead and punch this into Codewars and see what this looks like here. Alright, run the tests. And what is going wrong now? Cannot read property data of null. Ah! Okay, we got this edge case we need to account for here. So if root node is equal to null, we just go ahead and return null right here. Let's go ahead and paste this part of our code into our Kata solution here. Alright, let's go ahead and hit attempt. And we are good on that. Finally, this last kata is directly related to the previous kata that we did. And here we are parsing a linked list from a string. So I'm going to go ahead and grab this node class here and paste this into this kata solution right here. Now, the goal of this kata here is to take the string that we just stringified from this kata solution here and convert it back into a linked list. Alright, what we'll go ahead and do here, I'm going to go ahead and train, do const parse, and we have our string right here. And what we'll go ahead and do is we're going to go ahead and split this string. First we need to handle the edge case here. If str is equal to null, we just go ahead and return null. Alright, what we'll go ahead and do, we're going to go ahead and take the string and split it into the pieces of data here using the space arrow space separator here. And what we'll go ahead and do, constant data equals str.split, and we'll use this as the token here, space arrow space. Alright, what we will go ahead and do is, alright, we're going to go ahead and create, first we'll go ahead and create the node that we're going to be returning here. Const return node equals new node. And that is going to be constructed with the first piece of data from our string here. And what we'll go ahead and do is we're going to do parse int data at 0. Oh, wait a minute. I have another idea. What we'll do is we're going to go ahead and reverse that right here. And what we'll go ahead and do, we're going to iterate for let I equals 0, I is less than data.length, or rather, for const datum of data. What we're going to go ahead and try doing here, we're going to let return node equal null. And here we'll do return node equals new node. And we're going to pass in our number here parsed into an integer here because this data will be represented as a string here at first. And then, depending upon we are going to need that index then again. For let I equals 0, I equals data.length plus I. Anyway, what we're going to do is return node equals new node. We're going to pass in our piece of data converted into a number. Remember, this is going to be represented as a string here once we split them up here. Parse int data at index I. And then what we'll go ahead and do here, we're going to check to see if I equals 0. And then if it is, we're going to pass in null for this one. Otherwise, we're going to pass in a return node right here. Alright, this should work. I'm going to go ahead and do return node here. Alright, this should work because our resulting array is reverse. Will be reversed. Alright, let's go ahead and we're gonna hit we're gonna go ahead and copy this text here, and we're gonna do console.log, or rather const test equals parse. We're gonna paste this text in right here. I'm gonna do a console.log test right here. Let's go ahead and test this out here. Warm node, warm up parse linked list, and we start with 0 here. Next node, data 1 next. Alright, what we'll go ahead and do is instead of const, I'm going to do let test equals parse. And what we're going to do is while we're going to do while test.next is not equal to null. And what we'll do here is we're going to do console.log test.data. And then what we'll do here is test equals test.next. Alright, we're going to go ahead and test this out here. We have a 0, 1, 4, 9, and 16. And the while loop ends with null here. 1, 0, 1, 4, 9, 16, null. So I think this is going to fly here. Let's go ahead and punch this into Codewars and see what this looks like. And what is going on here?
Next object. Test on next here. No, 4, 9, 16. Oh, that's was not what we were expecting here. Okay, parse int data. Yeah, we start with the 16.
Oh, wait a minute. Let's try that. Oh, data. That ain't gonna do either. Okay, I think we need to pop the null out of there here. Try that. Yeah, I think we need to pop the null out of there here. So data shift that null out of there. We have our 0. We have our next. Yeah, get rid of this null case right here. I think this will do here. Let's go ahead and punch this into Codewars and see what this looks like. And we are good. That concludes today's warm-up segment. I will see you in the next kata. Given an array of numbers, and a number representing a number of beggars taking regular turns taking the subsequent values in that given array, the goal of this kata is to return an array representing how much each beggar was able to take. For example, according to the kata instructions, given the array 1, 2, 3, 4, 5, and 2 beggars, this kata function would return an array with the numbers 9 and 6, as the first beggar would take 1, 3, and 5, and the second would collect 2 and 4, assuming that they are taking regular turns. Let's go ahead and give this a try here. Alright, what I think we'll go ahead and do here, we're going to do something quite similar to what we did in one of the warm-up katas today. And it involves using the modulo operator to wrap around this values array here. Alright, what we'll go ahead and do is, first we need to create our return array. We're going to do const result equals new array of count elements. We're going to fill those elements with 0 here. And that is going to be what's returned here. Alright, we're going to go ahead and iterate over. We are going to go ahead and iterate over each of the values of our count here. I think we'll do 4. Let I equals 0, I is less than values dot length plus I. And what we'll go ahead and do is we're going to do result at index I modulo count plus equals I right here. Now, to reiterate what I said in the warm-up kata here, what this is going to do, this is going to take the element of our results array at index I modulo count here, because I is certainly going to go out of bounds of our result array here. This is a little bit, we're going to take this I here and divide it by count and get the remainder here. This ensures that if we go out of bounds of this array, this wraps back to the beginning of the array here. So, for example, if we passed in 5 for this count here, and this values array had more than 5 values here, once we were to reach, I think it's index 5, remember arrays are base 0, 5 would be out of bounds here and would otherwise throw an error. So, but if we took 5 modulo 5, that should give us a remainder of 0 here. So instead of 5, this would index 0 here. It would wrap back to the beginning of the array. Let's go ahead and test this out here. We're going to do console.log beggars. We're going to pass in that 1, 2, 3, 4, 5 that we saw in the kata instructions here, and we'll pass in 2 for the number of beggars. And let's test this out here. Node English beggars, and we have 6 and 4, and that's actually not what we want here.
I expected to see 9 and 6. 0. 1, 2, 4, 6, 9. 1, 2, 4, 6. 1, 2, 4, 6. Now we're going to go ahead and console.log that here in our for loop here. Let's see where we're going wrong here.
Right. Values at I. And I see where we're going wrong here. We were adding the index itself to the current value of the results array rather than the number in the values array at that index. Let's try that again, and we do get our 9 and 6 like we were expecting. Alright, let's go ahead and punch this into Codewars and see what this looks like here. We're going to go ahead and run the tests. And we are good. Where I was going wrong with this Kata solution was, instead of adding the value at the current index of the values array to the element of the results array at the current index, I was adding the index itself. Let this be a lesson to always pay attention to what you're typing whenever you are coding. Here we are counting loose change, given a number representing the number of cents in your couch, in your pocket, in your wallet, what have you. The goal of this kata is to return the least amount of denominated coins, quarters, dimes, nickels, and pennies, respectively, needed to make up that amount of money here. Now, some important notes in the kata instructions here. This function returns 0 if it's given a 0 or a negative number. And if a floating point number is passed in, that floating point number needs to be floored, rounded down to the previous integer. Let's go ahead and give this a try here. First, let's go ahead and handle our edge cases here. If cents is less than or equal to 0, then we return 0. Then, yeah, we return the blank. First, let's go ahead and create that object here, actually. We're going to go ahead and do const result equals this. Quarters, 0 dimes, 0 nickels, 0 and pennies, 0. Alright, let's go ahead and handle the edge case right here. If cents is less than or equal to 0, we would go ahead and return our blank result here. Alright, first we need to go ahead and take our cents here. In case we are given a floating point number, we need to round that down to the previous integer here. And we can do that with the math.floor function. Alright, with that handled here, what I think we'll go ahead and do is
Back to 25.
yeah, I think we can use the floor function to get the number of quarters here. Let's have a look at that. We're going to go ahead and do a little bit of a test down here. Console.log. Loose change, pass in 56 here. What I'm just going to go ahead and do right now is we're going to return cents math.floor cents divided by 25. I'm going to do node loose change, and that should give us 2 quarters. So what we'll go ahead and do is result.quarters equals cents math.floor cents divided by 25. We're going to go ahead and return our result here, down here. Then we'll do result actually, yeah, what we'll do here, we're going to take our cents, then we'll take our cents and subtract that. Then we'll repeat that with our dimes here. Result.dimes equals math.floor cents divided by 10. Repeat that. Then we'll go ahead and do the nickels. Math.floor cents divided by 5. That should give us 1 nickel, and we'll do the remaining number of pennies here. And that should give us 2 quarters, 0 dimes, 1 nickel, and 1 penny. Now this looks a little bit convoluted here. There's another way we can do this here. But first, let's go ahead and submit this to Codewars and see what this looks like here. Alright, we are good on that. But before we move on here, I want to show you another way we can do this. I kind of like doing this way better. It involves us using a while loop here. While cents is greater than 0. And what we'll go ahead and do is, if cents is greater than 25, we will do result.quarters plus and then cents minus equal 25. We did something similar with a Roman numerals kata several episodes ago here. We'll do cents is less than greater than 10, if cents is greater than 10. And we'll do result.dimes plus, and then we'll subtract 10 from our cents here. And then for our nickels here, we're going to copy this. I'm going to copy this. 5. And we're going to increment our nickels here. And then we'll subtract 5 from our cents. And finally, we're going to go ahead and do result.pennies equals cents. And I think we'll go ahead and break here. Alright, let's go ahead and punch this into Codewars and see what that looks like here. Should give us the same result. And no, it doesn't. Value. Because, this should be greater than or equals here. Alright, let's try that again here. And we are good. Here is another way to get those coin denominations without subtracting the cents that we pass in. Here, pay mind to the code snippet you see below me here. First, we get the number of quarters by taking the cents, dividing it by 25, and then flooring the result, just as we did in the first iteration of our Kata solution here. Now, to get the dimes, we do that very same division, divide the cents by 25, but this time use the modulo operator to get the remainder instead. We take that remainder and divide it by 10, and then floor that to get the number of dimes we need. Next, for the nickels, we do that very same thing as before. Take the cents, get the remainder of it divided by 25, and then we get the remainder of that remainder divided by 10, and then we take that remainder and divide it by 5, and floor that to get the number of nickels we need. Finally, we take the cents, modulo that by 25, modulo that remainder by 10, and then modulo that remainder by 5 to get the number of pennies we need. In so doing, we should get the number of denominated coins that we need to make up the number of cents that we pass in without ever subtracting from the number of cents we pass in. Given a node object representing a binary tree, the goal of this kata is to add together the values of each node in the binary tree. I want to call your attention to the kata instructions right here. Here is the description of our node here. Our node has a value represented by an integer, and two values left and right, each one pointing to either the next node in the tree or null if there is no next node in that particular branch of the tree. Absence of a node will be indicated with a null value. Let's go ahead and give this one a try here. Alright. I think we go ahead and Alright, we have the value of our root node here. I think we go ahead and return root node dot value plus, let's see here, root node dot left or 0 plus root node dot right or 0. Alright, let's go ahead and try that here. Console.log. We're going to go ahead and set up a little node here, binary tree here. Const tree equals of our value. We'll set that to 10. Our left, we'll set that value to 1. Left null, right null. And then right, value 2, left null, right null. And then we'll go ahead and do a console.log down here. Sum the tree values, and we'll have our tree right here. Let's go ahead and test this out here. Node sum the tree. 10 object, 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 object. Alright, we'll go ahead and correct that here. Root node dot left. Sum the tree value. Okay, what we'll do here. Yeah, what we'll go ahead and do here is we'll return the root node, the value of our root node, plus, depending upon whether root node dot left is null or not, we'll do sum the tree values on the left node. Otherwise, we'll do a 0 here. Plus, we'll do this very same thing with the rightmost node as well. I'm going to go ahead and replace these with the right. Let's try this. That gives us 13. And that is what we wanted to see here. Alright, let's go ahead and try out another tree here. Let me go ahead and get rid of this terminal here. Alright, this root node is going to have a value set to 1. And our left node here, we're going to do a value set to 0, left to null, right to null. And then our rightmost branch of this root node here will set a value to 0, left to null, but we'll set our right branch to another node here. This value is going to be set to 2 with a null left and a null right. Alright, let's go ahead and test this out. And we get 3. That is what we wanted to see here. Alright, let's go ahead and punch this into Codewars and see what this looks like. We're using a bit of recursion here for this one here. Let's go ahead and hit test. And we are good. In our Kata solution, what we were doing, we were null checking the left and right branches of our binary tree node, adding their values together or 0, depending on whether they were null or not. What I could have done better in this Kata solution was to save a null check and check the validity of the binary tree node itself. If this was null, the function would have just returned 0. Otherwise, it would have returned the return values of our recursive sum the trees function added together. Here we are implementing a function called zipWith. Given a function and 2 arrays, this function zips the arrays together, applying the given function to the 2 arrays to each pair of numbers of those 2 arrays at a given index, and then returns a new array with whatever that function will return. Let's go ahead and give this one a try here. First, we need to determine which of these 2 arrays contains fewer elements. What we'll go ahead and do is... I have an idea. We'll take first and second, do a destructuring assignment here. And what we'll go ahead and do is first, second, dot sort A, B, A dot length minus B dot length. All right, let's go ahead and console.log those and see what that looks like here. Console.log first, second. We're going to do a console.log down here. We're going to go ahead and pull this math.pow call here. We'll do a console.log. We're going to paste that in our local solution here. Let's go ahead and test this out with Node and see what this logs after our sort here. Node zipWith.js. That should give us 10, 10, 10, 10, 0, 1, 2, 3. That does not change the array at all. That's what we're looking for here. But what if that might not be the best idea here. Alright, I have a new idea. Alright, we're going to pretend I didn't say anything here. So, what we are going to go ahead and do is... How about we get the minimum of the lengths of these arrays. We'll do const min length. We'll do math.min first.length and then second.length. And then what we'll go ahead and do is we're going to go ahead and keep track of a results array. And that is going to be what's returned here. I would like to try something here. Maybe the first, I think we'll just go ahead and do the for loop here. For let I equal 0, I is less than min length plus I. And then what we'll go ahead and do here is we're going to go ahead and do results.push. And what we're going to push into this results array is the return value of the function that we pass in. So we'll do func, and we're going to pass in first at index I, and then second at index I. Now, according to the Kata instructions, if the arrays are of non-equal length, the output will only be as long as the shorter array. So values of the longer array are simply not used. Values of the longer array that are at an index larger than this minimum length here are simply not used. Let's go ahead and feed this in a node and see what this looks like. And we get a result array with 1, 10, 100, and 1000. Because we are feeding in we are calling the math.pow function with the numbers at the given indices here. So we have 10 to the power 0, which is 1, 10 to the power 1, which is 10, 10 to the power 2, which is 100, and then 10 to the power of 3, which is 1000. Alright, let's go ahead and pass this into Codewars and see what this looks like. Alright, we're going to go ahead and run the tests. And we are good. Now, I think it's time we had a little discussion about the arrayObjectsFrom method. The arrayObjectsFrom method allows you to create new arrays from array-like objects like strings and sets, using custom mapping functions and this context if so desired. The method takes up to 3 parameters. The first parameter is the array-like object that you want to convert into an array. Now, you could also use an object in here with a length property to create a new blank array with that many blank elements. In this particular case, I could have used that approach using the length, setting the length property to the minimum of the lengths of the 2 arrays that we passed into our Kata solution here. The from method's second parameter is a mapping function, which iterates through each of the elements of the newly created array and sets those elements to the return value of this mapping function. In this particular case, I could have used a mapping function which took 2 parameters, the element itself, which we would not have used, and the index of that element. And I could have set the return value to be the return value of the function that we pass into our Kata solution, passing in the elements of the 2 arrays that we pass in at the current index specified by the predicate function's second parameter. Now, the third parameter, which I will not be going over here, would specify a custom this context. Now, by going forward with this approach right here, it would have been possible for me to implement this Kata solution in just 1 line. According to a tale, Josephus was an ancient historian who, with his 40 soldiers, were trapped in a cave by the Romans during a siege. Refusing to surrender, they instead insisted on mass suicide with a twist. They formed a circle and proceeded to kill 1 man every 3 until one last man was left over, and that man would kill himself to end the act. Well, Josephus and another man were the last 2 remaining, and they did not exactly follow through with the original idea. Which brings us to this Kata right here. Given an array and an integer, the goal of this Kata is to return what's called a Josephus permutation of the initial array, and permutating the elements therein as if every k elements, k being the integer that we passed in, are counted out on a circular basis and placed into another array until that initial array is empty. The permutated array will be returned. Now, pay mind to what you see in this diagram here. Here we have an initial array, 1, 2, 3, 4, 5, 6, and 7. Now, we start at 0 and then we count 1, 2, 3. And then we go ahead and count this particular element out right here. Now, then we go ahead and count 3 again, this time from 2 here. 1, 2, 3. And then we count out 6. And then from the 5 here, we count out 1, 2, 3. So we count out 2 here. We start from the 1 again. 1, 2, 3. We count out the 7 here. Now we start here. We count 1, 2, 3. 5 is counted out. We start the 4 here. 1, 2, 3. 1 is counted out. And then 4 being the last element of our initial array, we count that out right here. And as a result, we should have this permutated array right here. 3, 6, 2, 7, 5, 1, 4. Let's see if we can replicate that right here. Alright, let's go ahead and get started here. We're going to have a result array. We're going to set that right now to an empty array, and that is going to be what is returned. Alright, with this, I think we are going to need a cursor here. So we're going to set a cursor variable here. And we're going to set that equal to -1. So we're going to add 3 to this -1 here. And we're going to 0, 1, and 2. And if I'm not mistaken, that should give us the first element that we want to pop out. Then we subtract the cursor by 1, and then we start at 2, and then we go to 4, 5, and 6. And that should give us the next number we want to pop out here. Then we subtract the cursor by 1 again, and so we have the 5 here. So, yeah, 0, 1, 2. 1, 2. 0, 1, 2. 1, 2, 3, 4. 3. 4, 5, 6. 5. 6, 7, 8. Okay. I think it's... Let's go ahead and try this. 1, 0, 1, yeah, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7. Okay, I think I know what we're gonna try doing here. We're gonna do a while loop here, and we're gonna loop until our items array is empty. So while items.length is greater than 0. Alright, we're going to go ahead and advance the cursor by k places here. Now, what we can go ahead and do, 0, 1, 2, we need to get the index of the element that we need to count out here. So we're going to go ahead and keep track of an index here. We're going to set that equal to -1 at first. Now, in our while loop, we're going to go ahead and set the index here to our cursor modulo items.length. So we started our cursor at -1. If we advanced it, let's say 3 places here, that should land us on index 2, which should be our 3 here. And then once 3 is counted out of this initial array here, it should no longer exist in this array here. At the end of the while loop, we're going to want to go ahead and decrement the cursor right here so that it's set to 1. So what we're going to go ahead and do, first we're going to go ahead and grab the element at that particular index here. We're going to do element, and we're going to set that equal to item, the element at our items array at index here. Next, we need to go ahead and count this 3 out right here. And we're going to go ahead and do that by doing this. Items.splice. We're going to delete at this index here, and we're going to delete 1. That should count this 3 out of this initial array right here. And we're going to go ahead and console.log that right here. Just for demonstration purposes right here. We're going to ignore this return right now. Now, we're going to try testing this out right here. It should give us 3, but It gives us 3, 7, 5. Yeah, that's definitely not what we want here. So, yeah, I had mentioned before that we're going to want to decrement our cursor each time we remove. Each time we count out one of our elements in our initial array here. So we're going to do cursor minus minus. Decrement that cursor by 1. And so that gives us... It's a little... it's closer, but it's still not what we want. So we're going to go ahead and console.log the current state of our items array here. We're going to go ahead and run that here. So we have our 1, 2, 3, 4, 5, 6, 7. 3 is counted out. So we go 2, 1, 2, 3, 4. Then we advance 3. We decrement 1 from the cursor, so we're back to the 2 here. 1, 2, 3. That should give us our 6. Our 6 should now be counted out. We decrement our cursor again. We go back to the 5. 1, 2, 3. Our 2 should be counted out now. So we go back one place to the 1 here. One, 2, 3. Now this is where we're going wrong here. We're going to go ahead and log our cursor here. Or rather, our index. Or maybe we do this. Cursor equals index minus 1. Wait a minute, I think that may actually have been it. Alright, let's go ahead and... I think that may have actually have been it. Let's go ahead and push this element into our results array here. And let's see what this spits out. We get 3, 6, 2, 7, 5, 1, 4. And that is actually what we wanted to see here. So, we were going wrong is we were decrementing the cursor itself. What we actually wanted to do, we wanted to set this cursor to the state of the current index minus 1. So, let's go ahead and test this out with some other test cases here. How about this one here? Expect to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How about setting this to 2? 2, 4, 6, 8, 10. 3, 7, 1, 9, 5. Yup. How about Codewars here? And we get ESWOCDRA. ESWOCDRA. Yup. I think I am feeling good about this. Let's punch this into Codewars and see what this looks like here. And we are good. Here is the better code solution of the day. Pay mind to the code snippet you see below me here. We do the very same while loop that we did in our Kata solution. Only this time we get the current index by taking the current index and adding k to it, and then subtracting 1, and then taking that result and dividing it by the length of the items array as it is right now, and getting the remainder, such that we wrap that number inside the bounds of the array. Next, however, we use the array object's concat method to concatenate 2 arrays together. The 2 arrays in question in this case being our result array and the return value of the array object's splice method to splice the element being counted out of the item's array. The splice method does actually return an array of the elements being spliced out. After all that, we go ahead and return the permutated results array as we do in our Kata solution. And that will do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there's anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. Also, if you are a Kata author on Codewars and would like to share your authored katas with me, feel free to drop links to those katas in the comments section below as well, and you may see me tackle some of those katas on a future episode of Versus Codewars. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.